This video goes over the area and perimeter of a parallelogram. So for starters, what defines a parallelogram? Like a rectangle, number one, like a rectangle, it is a four-sided enclosed figure. So here would be a four-sided figure that's not enclosed. So again, it's like a fenced-in area. There's no breaks in the fence. And it has sides, and these sides are come together at what are called vertices. This is a vertex, and the parallelogram has four vertices in the plural. So vertex, V-E-R-T-X, and then the plural is vertices. You could name these vertices A, B, C, D, or whatever letter you want. And then you could call this parallelogram ABCD or parallelogram ADCB. It doesn't matter whether you go clockwise or counterclockwise when you name the parallelogram. You could start at any vertex. This could be parallelogram CDAB or parallelogram CBAD. So again, for example, we could call this parallelogram ABCD. Could call it A, D, C, B. There's many different combinations of names. You can start at any vertex and go clockwise or counterclockwise as long as you go to consecutive. That is, consecutive means next to vertices. Then the opposite sides of parallelogram are parallel. Parallel, remember, means that two lines that never intersect are parallel. Intersect means comes together. So these are actually just line segments, but if you extend the segments forever, they never will intersect. So these two segments will never intersect, and these two segments will never intersect. It can be shown through proof that some of the following things are also true for a parallelogram. There's other things besides these, but these are kind of important. The opposite sides are equal in length. Turns out they are congruent or equal in length. And angles that are diagonal to each other, in fact, are equal in measure. So these two angles here, let's name this again. Let's name this parallelogram A, B, C, D. So the measure of angle A, I use a little m for measure. The measure of angle A, so this means the measure of angle A equals the measure of angle C, they're diagonal angles, and the measure of angle B equals the measure of angle D. This can be shown using proof. Okay, the relationship between parallelograms and rectangles. Well, it turns out that two lines that are perpendicular to the same line are parallel. Remember, perpendicular means right angle. So here's a case where here you have a line, this is a line segment, but if you extended it as a line, and these are line segments, but extended they are lines. So here's two lines, call this line A and line B. They are perpendicular to, let's call this line C. They're perpendicular to the same line. Well, it turns out if this is true, they are parallel. So in fact, in a rectangle, you have this very situation. Here is a line, and here are two lines that are perpendicular to this line. So these two lines here must be parallel. And likewise, these two lines are perpendicular to this line, so they also must be parallel. Therefore, a rectangle fits the definition of a parallelogram, where a parallelogram is a four-sided figure where opposite sides are parallel. So all rectangles, using what's called a Venn diagram, the set of all rectangles is a subset of the set of parallelograms. So all rectangles are parallelograms, but there are parallelograms that are not rectangles. So for example, if I put an X in here, this would represent a rectangle, and it's also a parallelogram. However, if I put an X out here, This represents a parallelogram that is not a rectangle. So here, this would be an example of a figure that is a rectangle and a parallelogram. Here, however, here's a figure that's just a parallelogram, not a rectangle, because in this case, these are not right angles. This is an acute angle here and here. And these are obtuse angles. Next, I'm going to talk about the altitude or height of a figure. This is an important idea in geometry and will be necessary to calculate the area of say, a parallelogram and later a triangle and trapezoid. So the altitude or height is the distance. So imagine I have a ceiling and floor, and they're parallel. The distance from the ceiling to the floor would be the distance that if I dropped a rope straight down, that would be the altitude or height. Notice that the rope will intersect the ground at a right angle. Any other place where the rope hits the ground will not be the shortest distance. So the altitude or height is the shortest distance from the ceiling to the floor, and it's going to intersect at a right angle. For example, if I extended the rope, or let's put it this way, put the rope in this position or this position, the length here of the rope is the same, but notice it is not touching the floor when you come out like this at a slant or at a slant like this. Now these are actually the radii or radius of a circle, because this is an arc here in green. And if you continue around, that forms a circle. It's clearly not the shortest distance when you go at a slant line, because to get the floor I have to add an additional length here from this length here, and these are all equal. And the same thing here. So the shortest distance from the ceiling to the floor is going to be the perpendicular. And that's also true if I have a single point. Let's call this a point P. You don't even need to have you just have to have a floor, but the shortest distance from the point P to a line is going to in fact be the perpendicular. So the shortest distance from a point to a line is the perpendicular line. Which I've illustrated right here. This is the perpendicular line, here is the perpendicular line. Any other line is going to be a longer distance, and this is the altitude. This line is called the altitude or height. So now let's derive the area of the parallelogram. So I'm going to start with a parallelogram, and then I'm going to draw an altitude at one of the vertices. So remember the vertices, I could call this like A, B, C, D, and let's just say I draw one at vertex A. So I draw an altitude, so I drop a line straight down from A to the ground here. It hits at a right angle, and I have a triangle here. So next I do is I cut this triangle, and I move it to the opposite side, like so. And when I put it in place, I will get a rectangle. And we already know that the area of a rectangle is base times height, or B times H. And in fact, the B of the parallelogram is the same as the B for the rectangle, as is the height. So the area of a parallelogram, in fact, is also base times height, or B times H. So let's just understand, though, you don't have to do this operation to calculate the area of a parallelogram. You just have to measure the base and height of the parallelogram and then multiply them together to get the area. So now, more generally, here's a parallelogram. I have a base B, a height H, and there's your altitude, which is H, and I have the two sides here, C. These are both going to be congruent or equal because they're parallel, and they're going to be equal in the case of the parallelogram, and these are also going to be equal in length. So the area is just B times H, or BH, and the perimeter is the distance around. Well, I have two B's, Actually, I shouldn't call this C. Let's change that. This is also A because these are congruent in the case of parallelogram. I'm sorry. That can be proven. So this is 2B plus 2A or 2A plus 2B. So it's just like the perimeter formula for the rectangle. So now let's do an example. So the area of this particular parallelogram would be A is B times H, where B is 10.1. So that's my B. And my H is 3.1. So I'm going to replace B with 10.1, and I'm going to replace H with 3.1. So the area is what you get for the area is when you multiply these together. So 10.1 times 3.1. Add a placeholder 0 for the second row. I have to shift it over. That's 1 times 3, 0 times 3 is 0, 3 times 1 is 3. Move decimal point 2 places to the left, so that's 31.31 square feet. And the perimeter of a parallelogram is 2B plus 2H, 2B plus 2A. So there's my B, and my A here is 4 because this also has to be 4 feet here. So I have 2 times 10.1, that's my base. I'm replacing my B with 10.1, plus 2 times A, and A is 4. So again, you could also call this, you're evaluating the expression when A is 4 and B is 10.1. Well, 2 times 10.1 is 20.2, and 2 times 4 is 8. And when you add decimals, you must line up the decimal points. So 8 doesn't show it, but there's a decimal point behind it. I'll add a placeholder 0. So now this is like 202 plus 80. So that's 282. So this is 28.2 feet. And remember, perimeter is just feet. Area is the space inside, so that's going to be square feet. So we're asking, in the case of area, how many little square feet, which is 1 foot by 1 foot, fit inside that parallelogram. And we found in this one it's 31.31 square feet. And this concludes the video.